So today we're going to take a look at an interesting subject, and it's one I didn't know very much about until I started looking at it recently. And that's reverse engineering third-party Android APKs. But before we get into that, if you all have any questions on this video or any of our other articles or videos, go ahead and check us out at ringzerolabs.com. We have a bunch of articles and write-ups and contact us information if you all have any questions on anything. But for now, before we get into the actual reverse engineering of the APKs, it's really important to understand a couple terms as well as different tools. Now the tools, when I started looking into this, I was inundated by all of the tools that are out there, but I've pared it down to just the things you need to get started and just the things you need to actually reverse engineer an APK without going through the whole gamut of, well, this tool does this one particular thing, and this one does this and that, and this and that. We'll just go through the few that actually get the whole job done. So we're going to start here up at the top, and first term is just APK. It's just a good way to think of it. It's the Android application package. It's the app, so to speak. And essentially it's just a zip file. It contains a bunch of other files within it, like resource files and things like that. And the next term is a Dex file. The Dex file is actually inside the APK, so it's inside that zip. And a good way to think of this is that it's the actual compiled Android binary. So the equivalent of this in Windows would be like a compiled executable. The next part is also within the APK. It's called a manifest file. The actual name is going to be Androidmanifest.xml. And essentially what this XML file details is a whole bunch of information about the APK. Settings, permissions, various details, the install name, a whole slew of things, so you can get a very good overview by reading through this XML file. In the APK just raw, if you unzip the APK, the manifest will actually be in a binary XML format. So you need a tool to convert that to a readable format that you can just read through plain text. But we'll get to that later. And then the next term is Smalley. I had some issues understanding this at first when I was reading through it, and then I realized what it actually was. The best way to think of it is just assembly language for Android applications. It's the easiest way I can explain it. So if you're familiar with reverse engineering executables, x86 or x64, just think of Smalley language as assembly. It's going to look very similar. You'll see an example of it later. But yeah, so with those terms out of the way, we'll go ahead and start into the tools. I'm not going to explain how to install these tools in a Linux distro. All of these tools have installation instructions out there, and they're fairly easy to get a hold of. But if I were to detail the install of each one of them, this video would probably be an hour long. But the first tool, very important, is called APK tool. And what this does is take the zipped APK file and it breaks it out into all of its parts. So all the resource files, it decodes the binary XML, it gets all the Smalley, so that assembly language type stuff, out into a readable format, and it puts it all in a single folder. The APK tool can also build an APK, not just disassemble one, but it can take that folder structure that it disassembled it into, and if you go in and modify some of the Smalley files, change something around, you can then build it from that structure again and turn it back into a single APK. So that tool is very important. The next two tools are called Dexter Jar. They're part of the package Dexter Jar. And the APK sign is for when you build an APK, it's going to be unsigned. In order to install it onto a phone or an emulator, it has to be signed with a key. So this Dexter Jar APK sign is just a simple tool to sign that APK without having to do a very long command line argument to the Java I forget what it uses to sign it, basically the RSA key, generating the RSA keys and then signing the binary. It's much easier to just run this little tool. And then next is Dexter Jar. So this is part of the same package again, and what it will do is turn an APK into a jar, so it converts it into a Java jar. And why you want to do that is for the next tool, which is called JADX. JADX will take that jar file, turn it into Java class source files. So what that means is that instead of having to read through Smalley code, so the Android assembly code essentially, you can get a good representation of what that code would actually look like in a higher level language, in this case Java. Now it doesn't disassemble everything 100% correctly. You're not going to be able to take this source code and recompile it again into an APK, but it allows you to read through the Smalley and have a side-by-side comparison to Java. So that's very helpful. The next tool is something that comes with the Android SDK, and you can get that off of the Android SDK itself. You can get off of Android's website, and that is ADB. So ADB is just a small tool in the platform tools directory that allows us to install and uninstall APKs from an emulator. And we'll see an example of that later. Android Studio is kind of an all-encompassing package. So you get that off of Android's site, and what it is just, if you've ever coded C++ or anything like that in Visual Studio, it's just an IDE for Android. So Android Studio is an IDE for Android, and it comes with all the other tools that you need to develop those Android applications. So it'll have an SDK manager, it has an emulator manager, a whole bunch of things, and we're going to need that for debugging later on. And the next tool is called Smalley IDEA, or IDEA, Smalley IDEA, I'm not sure. But essentially what it is a plugin that you can install into Android Studio, and it allows you to debug native Smalley code. This is very important because I believe it's the only thing I found out there that can do it, and this was the thing that I was lacking the most when I was trying to reverse engineer third-party APKs, was the ability to debug the application. With normal reverse engineering, you have executables in x86 or x64, and there's a multitude of debuggers you can throw it in to step through the code and figure out what it's doing. For Android APKs, without the source code, you were essentially unable to do that. You could turn a third-party APK into debug mode and attach to it, and you could maybe get some debug log statements if those were enabled or something like that, but you couldn't actually pause the code and step instruction by instruction and inspect registers and variables and things. This Smalley IDEA plugin allows you to do that. It's very, very powerful. And then the next tool, fairly simple, it's FakeNet. And FakeNet I just have running on a separate Windows VM. And I have configured the base Linux box to use that Windows VM as the default gateway. So all network traffic from this VM is going to go to the Windows one. And FakeNet is just a way to mimic network services, so DNS and things like that. And it's going to provide responses back. So that's going to help us, if the APK is looking out, sending network traffic or something, we're able to capture that in a really easy format. Alright, so I believe that's it for terminology and tools. Fairly boring, but like I said before, there's tons and tons and tons of tools out there for Android analysis. But this is one of the better configurations that I've been able to find. So what we're going to do is go ahead and reverse engineer a benign program, so this isn't malware. This was just some chess game that I picked up off of Android APK game website. So there's nothing malicious about it. It's a really simple program. But I'm going to demonstrate how you take this third-party application that I don't have source code for, decompile it, turn it into a debuggable state, recompile it, install it, set breakpoints in the Smalley code, change some variables, and then actually debug to where we can step through the code. Alright, so here we go. Alright, so with the notes here, I had all the tools and everything listed. What I've found is that the beginning process is always repeatable, and then the second process that I used was always repeatable. So what I did was go ahead and make a shell script to go ahead and do that for me. So we have one choice and two choices. The first choice is going to decompile the APK. That is this. So Apktool D stands for decompile. So I'm going to decompile it into its own folder. I'm then going to build it and turn it into an unsigned APK. I'm then going to turn that unsigned APK into a jar. I'm then going to turn that jar into source files, so Java class source files. And then we're actually going to move those source files into the APK output directory. So I'll show you what all that looks like after I run it. So we're going to go to the desktop, and then I'm going to run my little script here, get the name of the APK. And then we're going to decompile it and generate the Java sources. And again, this is just using these tools. It's not using any trickery or anything. It's just instead of typing all of that out, I just have it do a script real quick. So right now it's converting the APK into a jar, and then that jar file is going to be, again, Java class files that we can read through a little bit easier. And like I was mentioning before, it's not 100% correct by any means. From getting the APK to, pseudo source back to Java, a lot of things don't decompile correctly, so it still shows up as Smalley, but for the most part, it does. Okay, so everything finished. So if we open up this file here, or this folder, this is what was inside the APK, minus this. This was what Dexter Jar did. And JADX. JADX turned it into source. So if we go into the source, we can look at one of these files. See that, oh, it's Java. Okay, so we can read through Java a lot better than we could read through Smalley. And Smalley looks like this. There you go. So this is the quote-unquote assembly language for the Android programs. After you look at it for a while, you can start to understand it, but reading through it straight is a bit of a hassle. So like here, if greater than equal v0 and v1, those registers to condition 0, go to condition 0, things like that. So as you get more familiar with this, you can start modifying this directly and change the execution flow of the APKs. But we'll get there soon. So now that we have this folder, the file that we want to look at real quick is the manifest, Androidmanifest.xml. And like I mentioned before, it has things like the package name, so that's what it's going to be called when you install it to the emulator. It has certain permissions here, so it needs internet access and access your cell network state, things like that. There's a whole slew of information in here. But the thing we're concerned with right now is we want to go to this application tag. On the end of it, we want to write Android debuggable equals true. And that's it. So we need to add that to the end of the application tag and then save it. What that's going to do is when we recompile a new APK from this folder, it's going to compile with the debug flag on, so that's going to allow us to attach to it in the emulator. If we didn't have that on, it wouldn't allow us to attach to it. So now we're done with that. The next tool we need to open is Android Studio. And I just put mine in. I installed it, created a shortcut in reverse engineering. I'm using Kali based distro here. So if we open up Android Studio, so in Android Studio, once it's everything's up and running, you should have a couple icons over here. The pinkish one is going to be your AVD manager. That's going to be your emulators. So you need to open that, and you need to create a virtual device. In order to do this, you're going to have Android images, system images. And Android Studio will prompt you, if you don't have any, to go ahead and download them, especially when you've created a virtual device. You pick what screen size you want, and then you pick which image you want. Now, all of this is fairly tricky, depending on what kind of system, base system, like your actual hardware system that you're running on. In my case, I'm on a Apple MacBook, and it does allow hardware virtualization, so I'm able to use certain types of Android system images which start up much faster. If you don't have a base machine that is capable of that, you're going to have to use other images, and they're not showing up right now because I have fake net running on the other machine. But if I was connected directly to the internet, this would populate with a whole bunch of images off of Android's site. But if you don't have hardware virtualization enabled on your machine, or it's not capable of it, you'll have to run an ARM image, and those can take significantly longer, like 85% longer to actually boot up. But once you get it booted up, you can take a snapshot or something. That way you don't have to wait for it to come up again. But if you have the hardware virtualization on your machine, usually takes a minute or two, and the actual emulator will be up fairly quickly. So right now, what we're going to do is just start it. Just hit the play button, and there you go. It's already up and running. Alright. So now we have our emulator. So this emulates the phone, and we can do what we need to do. So now we're going to come back to the Android Studio, and what we're going to do is go to File and Open, and we're going to navigate to that folder where everything was output to. In this case, it's on desktop chess v2. now it's still opening. Oh, important thing I forgot to mention. Where are the plugins? Plugins, here we go. So if you go into the settings for Android Studio, when you get Small Idea, it's going to come in a zip file. So you're going to download that, and then you go to install plugin from disk. So you're going to navigate to it, and wherever the zip file is, you just click the zip, and it should install into your IDE. Once it's installed, it'll ask you to restart the IDE, and then you should be up and running. So really easy to install Small Idea. Now that we open the Chess v2 folder, Android Studio recognizes that there's a framework within it. So go ahead and hit configure, let it do its thing. Alright, there we go. Alright, so the source folder that I mentioned before, that was the result of JADX, and it decompiled into Java. So we can click the Java files and go through them, and you see here, there's a ton of math in the A class, and if we go up to a.smally, this is what it looks like in Smally. So a ton of math still, but even longer and more complex than just reading it through a.java. So you see where this kind of comes into play, where you can get an idea of what a particular Smally file is doing, so that you can maybe go in and find key values that you maybe want to pause on or edit, things like that. So when you find something that you want to pause on, let's say, in this in class, it's talking about too few spaces, invalid piece, invalid side, white must have exactly one king, etc., etc. You can go into in.smally and go find those same things. Invalid sides, maybe we want to pause on that. You put a breakpoint by clicking in the side here. Let's go up to a.smally. Let's just throw in a debug point here, maybe here. Let's go into G. Again, these breakpoints don't mean anything right now. I'm just going to try and get the code to pause. Yeah, that's all I'm trying to do. So maybe here, there. Okay. So that should be enough. Something should hit in the program. So what we're going to do is go ahead and back out of the IDE for just a sec, and I'm going to go back to the script that I wrote and change my argument to the folder. And what this is going to do, it's going to build the APK, install it, and build the APK, sign it, and install it into the Android emulator. It's not going to run it, it's just going to install it. And we'll see it show up right there. So it showed up as chess. Okay, good deal. So now we can go back to the IDE. And if we come up here to attach debugger to Android process, we can see that our emulator is listed, but no programs are listed. So what we're going to do is go ahead and click chess in the emulator. Now it's running. So we're going to come back and we see here that it is now listed to be debugged. So if we hit OK, we see this pop up down here, and now we are debugging the program. None of our breakpoints have been hit yet, probably because we're not playing a game and we put a lot of breakpoints and a lot of math. So that probably has to do with the calculations of where the pieces, where the AI is going to put the pieces. But before we go into a game, what we need to do is set up a watch list for variables, and that's with this little eyeglass icon here and the plus sign. Now with Smalley, they have a interesting variable set up for any kind of function or method. The arguments that are passed in can be referenced with a P0, P1, P2, etc., however many arguments are in the method. That's going to represent, P0 is going to be the first argument, P1, second, P2, etc. That does change if it's a private or public, I believe, but you just have to read up on that. It's yeah, it changes every now and then. But to actually monitor those registers, we can put in a P0, and then P1, P2. That should be enough. And then normal registers are going to start with V's. So V0, and then V1, V2, and I usually go up to about V9. So the amount of registers are going to depend on, again, the function. At the beginning of the functions, it declares a locals. Where's it at? There it is. A locals 3. So locals 3 means that there's going to be a V0, there's going to be a V1, there's going to be a V2. That's three registers. If you want, you can actually change that, and we can recompile the APK, install it again, and you can have more registers to mess with. But that's a more advanced topic. But for now, we have all of these watch lists for the variables. Now we're going to change this to the right side to make it a little easier to see the values. There we go. Alright, so I'm going to go back to the emulator now and start a game. And I'm just going to move a piece. Okay, nothing yet. There we go. Alright, so our debugger, our debug statement breakpoint was hit. And this is what hit. It's right here. Now, I don't know where this is. I haven't looked at this app. I don't know, what functionality this is, other than it's a lot of math. If you were actually reversing in the APK, you would, of course, go in and look through the Java code quite a bit, find interesting functions, maybe obfuscation functions, things like that, or relevant strings that you actually want to look at. Here, I'm just demonstrating how to get a breakpoint and what happens when a breakpoint hits. So, just like any debugger, you can step over instructions and you can step into. In this case, it's an F8 and F7 key. So if we go ahead and step, you can see that we can actually step through the data. Now the variables over here don't seem to be, not find local variable. Not sure why that is. Maybe if we and set a few more breakpoints. Oh, sure. Okay, so we're just going to continue. I'm going to get rid of that one. That's curious behavior. So these should be let me get rid of those. Try this again. Oh, okay. 2. Okay. So maybe that's a tip for later. If wait until a breakpoint is actually hit before you add the watches. They don't seem to show up until unless you do that. But here we can see that if we step, you can see that the registers are being populated with data. Now, depending on what that data is, it may or may not be able to be read, but if it's some sort of structure or something, you can usually drill down into it. If it's some sort of byte array or a string, they usually show up pretty well over here. If you're tracking a particular variable through a deobfuscation routine or something like that, you can step through and see how the variable changes. If there's something that you want to change, you can actually come over here and change the value itself. And if you want to actually change the functionality of the APK, so if there's some sort of jump you don't want, or maybe you want something to output to a debug log or something like that, you can actually change the functionality. Say we want to change this from a V2 to a V1. No idea what this does, and just an example. We can do that, and we can press Control S to save it, and that actually saved in the g.smalley file. That actually saved in this folder. What that means is that if I want to recompile the APK and sign it and install it, so now chess is back. We can see that it's still functioning, but whatever I did may mess something up in the program or cause it to behave differently. Again, I don't know what I changed, just changing something. So if we actually go in and find something else, maybe I think there was a beginner. So there's 2 values for beginner. Oops. I started the music. Beginner. There we go. So there is one beginner. There's another beginner. And no more beginners. So if we save that, this is just going to be in a resource file called strings.xml. Nothing really, not changing the output of the code or anything. We're just changing how something looks. So again, we're going to run this and build the APK, sign it, install it. and run it. And there we go. So the beginner that was listed up here is now hello. And the beginner that was listed up here is now hello too. Again, that's not a very significant change of any kind, and you can actually do that before very easily. The biggest part of this whole process is the Smalley Dia plugin, to where we can actually go to the Smalley, put a breakpoint, modify registers, view the contents of those registers, and manipulate the APK in a way that allows us to understand it better. So I hope this was informative. It was rather long, maybe a little complex, but this is, this was all new to me not too long ago, and this was the best way that I've found to go ahead and take third-party APKs, ones that you don't have source code for, turn them into a format of where you can edit them, as well as debug them line by line to figure out how they work and what they do. And again, these were the only tools that I used to do so, as well as Kali Linux. I'm just using that as a base machine, but you could use any Linux distro that you needed. And as long as you have these tools and a little bit of curiosity, you should be able to reverse engineer any APK that you need to. I hope this was informative. If y'all have any questions, go ahead and hit us up at ringzerolabs.com, and we'd be happy to answer any questions on this video or any of our other videos.